All right. Hello, everyone. Welcome to MATHurdays. Math's so fun. We do it on Saturdays. My name's Therese Wells, and I am here to share with you all a math routine and a rich task that can be done in an in-person classroom, but also in a virtual classroom as you're about to participate in today. The main focus is looking at elementary measurement. So that standard where students are working between standard and metric measurement systems and all the wonderful learning and confusion that can come along in that. So let's go ahead and get started. I assume if you're in here, you do have the links to the slides, but just in case, I'm going to share that with you now in the chat box. And the unique thing about the way that I teach is we use our slides for everything. Most of the time, we actually don't even have the cameras on. We have Google Slides open, and that's where all our interaction is. And on slide 2 is my contact information where you can go to reach out to me for questions that you might have. Slide 3 are where you're going to want to go for your bookmarks. So the first one is templates. This has a variety of different templates that I use in virtual learning. They come from in-person learning, and they can be used in hybrid or in-person situations as well. And the second link on slide 3 is where you can find over 50 other MATHurdays tasks, routines, and more, including the blank slide templates already created for you so that you don't have to do that step. All right, let's get interacting already. Come on down to slide 4 or 5, and you're going to add a success or a celebration. So it can be a text box that you type in. You can add an image. You can add more. This is your place to add something that's going on in your world. And those of you who are used to seeing me at home with my little circle video, you might notice I'm in a different place. I'm at my brother's house in West Virginia, which is really close to Morgantown. It's beautiful outside, just sitting out here right now. And my little celebration, I've got a picture of my kiddos there who went to this place called Potomac Overlook Park yesterday. And we got to see a hawk and 2 different types of birds right up close. And that was really cool. All righty. So who survived the first half of summer school? Turn on your microphone. Tell us what's going on. Any tips you have for other teachers? I'm not hearing anything. I didn't test my microphone before I got here. Let's see if it's me, throw it in the chat. If not, who said that they survived the storm with minimal damage? Where are you coming from, and how bad was the storm?
Oh, it was, I don't know. It just came out of the blue last night. It was, I don't know, 50, 60 mile an hour gusts of wind. I've got twigs all over the yard. A couple panels blew off the swamp cooler. So my husband will have a fun time fixing that today. But otherwise, yeah, survived with very little done, but I'm sure there's trees down all over the neighborhood.
Oh, goodness. Glad that you're safe and things are okay for you. Who just finished the David Costello webinar? I have found his resources to be incredible. What tips do you have for us?
This is Lisa, and I did a spiral practice class last year from Kyle and John in Canada, and I was going to start it this year, and with COVID it stopped, but this one that I yesterday just inspired me get going with it this year.
Very cool. Yeah, if that name is new to you, Google it. David's got a lot of great things just to kind of, it gets me interested and motivated. Like, oh, I want to do that. I want to do that. I want to do that. And, you know, that's always great to see with a resource. Who is viewing the beautiful Islamic art today?
Hi, Teresa. It's Kathy up in Edmonton. We have a place that's associated with our university, University of Alberta, and these are the Botanic Gardens. And so one of my favorite hobbies is photography. So you can go in at 8 a.m. and just be there before the crowds arrive. And I spent my time in this place called the Aga Khan area, and it's all Islamic art. So my theme today was geometry and finding shapes and thinking about angles. And so I did that and then rushed right home to join you this morning.
Oh, how cool. I love Islamic art. I like the specifically the number of repetitions. Boy, there's all sorts of transformations we could say here, but whether it has 6-sided symmetry, 8-sided symmetry, 12-sided symmetry, it's really beautiful and great for math class too. All right, folks. Well, again, welcome. Let's go ahead and jump right in to our routine. I'm on slide 6, and I'm going to showcase the routine called Caption This. This routine is something that I found hilarious in college, where someone would throw a picture up and you would try and fight to get the best caption that was the funniest caption. I'm sure there are math examples of this. I haven't found any yet. If you know of resources for Caption This, feel free to add it to the slide. But essentially, what you're going to do here is you're going to pick a slide below 7, 8, 9, 10, or 11, whichever one jumps out to you, and you're going to caption it. You could give tips about measurement. You could get funny, but whatever you do, caption it. There's lots of text boxes there, so people can have lots of opinions. But find one, and what would you caption? What would you write next to it? A tip or a funny meme? If you've captioned one, you are welcome to keep moving through and caption as many as you like. Hi there. If you are just joining us, welcome. On our slides, we're on slide 7, 8, 9, 10, or 11. You're finding a GIF that speaks to you, and you're captioning it. You're finding one of those little sticky notes and writing either a tip, something funny, just something to caption it. I always like to give my students a few minutes of silence there to get ideas rolling. And now I'm going to advocate for student agency here. So even though we're having a discussion, feel free to have the agency to move emojis and to not be on the same slide as us. If you want to move somewhere else and keep making funny jokes, you can. You'll notice off to the right, there's some different emojis. If you read somebody else's and you have a reaction to it, feel free to duplicate one of those emojis and just drag it over. It's a nice little way of saying, like, I really like what you wrote, or that was a mind blow, or I love this. And I'll ask a couple of folks to share out a little bit more. I'm going to give you a heads up that I plan on calling you so you don't feel like I kind of did cold calling. I'll make your text box yellow. On slide 9, who said when a friend is not helpful? What does this GIF kind of make you think of?
I actually said that it just reminds me of any time you get distracted by somebody and then all of a sudden you have to start all over again.
Yes, indeed. And how about the fish one? This is on slide 10. Someone wrote, throw it back. What does that mean? And I see we have a response in a chat box here. The fish is too small. No worries, Brian. You're always welcome to restart to try and fix your audio issue, but I also totally respect some people just prefer to use a chat box. So thank you for sharing. Yeah, so when you go fishing, you can only keep things of a certain measurement. And on slide 7, this little pup is trying so hard to help out. This one, it got 2 little emojis with it. Who wrote the one in yellow on slide 7? What were you thinking about here?
Buenos dias. Hey guys. Hi Teresa. This is Laura. That was me because that makes me think of every time we do measurement in our classroom, and literally every 4th grader ever says to me like, oh, I have to start at 0. Like this is a thing that they have never contemplated until they have reached the 4th grade, because we always try to measure things like around the classroom. And for some reason, they just start measuring in the like a random place in the ruler, and they never start at 0.
Exactly. And I love using this one for conversation starters because it's always funny to kind of, joke about this poor little puppy not really helping, but yet they're really bringing up some great mathematical ideas about measurement. And you'll notice this little GIF also, he doesn't end at the end either. So, kids really love bringing up all the things that are wrong with it. All right, folks, we have a bunch on here. What I want to do is direct you to slide 12. Whenever I choose to do a math routine online, I like to get really purposeful about the protocol that I did so that if teachers want to replicate it, they can. But I also want to advocate for teachers that there's no one way of doing it. This is just the way I did it. So I made sure that I found pictures or GIFs that were directly related to our measurement topic. I made sure students had choice. They could browse which one they would do the captioning for. And to make sure kids are always on task, they have the opportunity to respond to multiple. You can interact with each other through emojis. And we discussed ones that I thought would bring up our objective. Alrighty, hope you enjoy that routine. Let's jump right into our task. The reason why we do rich tasks is on slide 13. Today's task is a little bit more guided, but one of the things I hope that you see in it is the amount of choice and the generalizations that come out of having choice. And those generalizations will start to pop up naturally. I'll be listening in and watching on slides for when they pop up, and we'll be sharing those during our discussions. But before we get started, on slide 14 is where I have the problem-solving oath. I'm going to take a moment and read this out loud. I hope you read it also. And if this is something that you would like to pledge during our session today, you're going to type your name in the chat box. It says, I, insert your name, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. If you'd like to make that pledge, oh my goodness, I already see so many names in here. Fabulous. Let's jump right in. So if you join me on slide 15, I'd like to show you a demonstration of what's happening. But I also realize that sometimes my demos go a little fast, and it's always great for students to be able to reference it. So I have a video on slide 17 that does exactly what I'm about to do here. So you might be familiar with the fact that I love Pokemon. I did a proportionate Pokemon session, and this time we're going to measure Pokemon. And the way that we're going to do that is by going to this website for a Pokédex. And we're going to find one of these lovely little Pokemon to use. I'm going to use Blastoise. I'm a big turtle fan. And I see his height is 5 feet 3 inches. So I'm going to copy him. And I'm going to paste him on my slide. Wait, how big was he? Oh yeah, 5 feet 3 inches. And then I'm going to put it over here on the right, 5 feet 3 inches. But gosh, he's not lining up that way, so I have to make him that way. I have to keep increasing him, increasing him, increasing him, until he is the size he needs to be. Then I'm going to measure him based in centimeters and put the metric height next to it. So that's the entire task here. As you can see, it's pretty procedural here, but what you're going to do is come up with as many slides as you can. And then we're going to pull out generalizations. What are some things you notice about your numbers from standard to metric? And that's really what I'm going to be looking for. So if you need to see that again, directions are on slide 17 of how to do it. And your group slides begin on 18. Group 1, you'll be on 18. Group 2, you'll be on 20. Group 3, you'll be on 22, and so on. So that's our task. As I mentioned, I'll be looking for generalizations. Before we start, do you all have any questions, techie questions about how to do this? Feel free to put them in the chat there. I'll make sure I visit your group first. But for everyone else who's ready, I'm going to go ahead and create those breakout rooms. Alrighty. The rooms are ready. You'll just need to click the button to go into them. And if you're having trouble finding that button, you might need to close down your browser. Perfect, there we go. Welcome back, everyone, to the main room. I hope you had some time, fun time exploring this. This type of lesson I would typically do as introductory to units because it's more exploratory. Usually high interest. I find this age level knows a lot of interesting facts about Pokemon. And even if they don't know a lot about them, there's so much to choose. They're likely to find something that they like. And these kiddos, anywhere from 2nd to 5th grade, can definitely be seen in libraries, going over to the Pokemon section and getting the books. And all they are like indexes with facts about each of these. including standard and metric heights, weights, and more. And after we do this exploratory task, one thing that I like to do next is give them a richer task that says, we are going to like paper mache build one of these Pokemon. So you better get the height right. Which one are you going to make that's big enough that we can showcase it at like a science fair table, but small enough that it can fit on a desk? And so now they're using a lot of these measurements. They're within these bounds. And they can also use measurements like weight. And when I did this with a 6th grade class, because they were working on some other standards, they even made a Ghastly using a balloon. So they went to the dollar store, they got a Mylar balloon, and they decorated it so that it was the correct weight and it was kind of floating. While others put in sandbags in these really heavy ones so people could feel just how heavy these Pokemon really were. And they legit made them out of paper mache so you could see about the height. And it was just a super fun summer project that we did in that class. So this is the prep work beforehand. And what I'm going to showcase in this discussion are the great discussion points that came out because of the task. And I'd like to start with group 3 on slide 31. So I'm showing 31, that's where they are. And the big question is, how do we measure this Charizard? And group, could you kind of tell us a little bit about the discussion you had, the decisions you had to make? And I think someone even talked about a standardized test and a shoe. If you just kind of bring up that discussion to us, we'd love to hear it.
Hi. So our group, we were working with the Charizard, which is a very popular Pokemon. And the problem with the Charizard is that the Charizard, it was taller than the ruler on the page. So we had to we had to add on a ruler. And then we kind of got into a discussion about how the Charizard's toes, like I lined up the Charizard's toes with where the edge of the ruler would be, but that's not really an accurate way of how you would measure someone's height. You would measure someone's height like the bottom of their foot, not the edge of someone's toes. Like when you go to the doctor's office, the doctor doesn't tell you to stand on your toes. Like that's just not how that works. So I was sharing, our group was talking about how like 4th graders would be, my 4th graders, and if we were doing this, they would start debating with each other about how this was inaccurate because you don't stand on your toes. Like where is actually the height of the Charizard? And then are you measuring the height of the Charizard's wings, or because his wings are higher than where he is? And then that's where kids have sometimes struggle a little bit with, like, are you measuring a real object or a picture of an object? Like, is it the 2D representation or the 3D object? And that comes up when we're measuring height.
Yes, absolutely. And your group was talking also about the outline of the clip art box. If that was you that was talking about that, would you tell us a little bit about this this question and this thinking that you did?
So we were discussing the outline of the box because just as this one that we have here, we recognize that the box is greater than the actual object. And so when we put it there, were we measuring the box, or were we measuring the actual object? And so what we did was, such as Laura did on this one, she pulled it down so that the bottom of the object, the toes, were at 1 and then measured at the head. But then we also did one where we pulled the box up to 1 and then measure at the top of the box. And so those were the different discussions that we had in regards to that, because we thought, like, if this is 4th grade or whatever the lower grades are, the students would have those kinds of questions or thoughts.
Thank you for sharing. This is very real world. I was mentioning with this group, if you've ever ordered blinds or curtains, you will know that there are very specific directions on what you have to measure in the doorway or the windowsill. You don't measure from drywall to drywall, or in this case, from clip art edge to clip art edge. Instead, you measure the actual space that it would go to, in other words, the Charizard. So these questions, while they might seem distracting in the class, what they are like absolutely real world questions that they would have to answer. And many of you have measured the height of a wall. Maybe you were putting a picture frame up, and sometimes there are baseboards or kick plates at the bottom, and your ruler doesn't touch the ground all the way. So what are you going to do about that? Are you going to move the ruler out some? Are you just going to measure that and add it on? And so these are real world experiences that come out of these silly little Pokemon. Thanks, group 3. Group 1, I'd love to hear, Kathy, if we want to start with you, has a different perspective teaching in Canada, and then just kind of telling us about what you all discovered in your exploration.
Sure. On our slide here on the right-hand side in the yellow box are some things that I knew. And then as we talk more, and then when Teresa popped in and asked more questions, like, I actually know more than I thought I did. We are a metric country, but we still work in imperial. We call it imperial. Maybe there's customary and standard units, but imperial and metric is kind of how we work. And we use imperial in carpentry, like 2x4s and things like that. And even when babies are born, it's reported in grams, but we say, well, what is that in pounds? So we're not completely metric, just so you know. But I do know that 2.5 centimeters is 1 inch. So that's sort of what I was working on with my little Butterfree. And then Teresa popped in and she said, is there another unit you could use? And then I realized that we have our pretty typical school rulers that are 12 inches, which is a foot, which is about 30 centimeters. So that was another referent. But then I also know from doing work with my kids in class that I think you would have a yardstick. We have a meter stick. And the meter is about the span of my arms. And then with work with my kids, I know that I'm 165 centimeters, which is about 5.6. So I have these reference that I use so I can understand distance. I also know that 1.6 kilometers is the same as a mile. So there are all these things that, like in Southern Ontario, there's a lot of imperial. Many people there don't use metric because parts of Ontario are below the American border. So it depends on where you are in Canada too, and different units. And so we talked about, I think what the people before us just talked about, it's not the box around the Pokemon. You got to get the feet right lined up to the 0. We compared very different size items. On slide 19, we have a really small one from Brian. And we did compare to see if if the scales, we were curious about the scales, how accurate they were. And then when we did the math using the reference that we knew, it was pretty good. So go ahead, Brian and Raha, add anything else?
Yeah, one of the things that was discussed was the fact that not only are we using basically one conversion, we're using a couple of conversions because we're having to go from feet to inches and then from inches to centimeters. So one of the things I was talking about is this is a great way to look at it in terms of proportions as well, because you're using conversion factors to go from one unit to another, and you're also crossing spans from a customary measure to a more metric measuring system. So it allows students to see, oh, I can work both systems and find out what the equivalent is in a different system than what I may be customary to.
Beautiful. Yeah. So your group kind of discovered that there are these multiples of 2.5, 2.5, or if you're even more accurate, 2.54. This idea of 12 being an important number or multiple, and the idea of 30 being important. So we have these 3 kind of important numbers, which is great to continue to look for in different models. And that's exactly what group 2 was up to. They were finding this idea of like, hey, guess what? 30 is cool. And so they found some examples of when this 30 showed up in their work. So group 2, can you tell us a little bit about what you noticed in terms of multiplying and dividing with 30?
So when we started off, we were just moving around with the Pokemon from left to right, trying to get the measurement. But then Stacy tried out something where she took a line and she checked from 1 feet, getting 30 centimeters. And then we went on checking whether our calculations of what we did by just moving the images were correct. And then since it was still further on where you had inches into it, we went on and we divided it further. So we got 2.5. And then we cross-checked whether what we got, and then minutely moving about with the image to check whether actually it is accurate to the calculations we did.
I love it. So we have this idea of we know 2.54 and we know 12 in the previous group. 2 on slide 27. Let's just put a line and get something that we know. Now we know 1 foot is roughly 30. So we can use division to get down to that 12 and get down to that 2.54. So it's really neat to see the way that you scaled up and scaled down in group 1 and group 2. And so both of those concepts will continue to come up in measurement. All right, folks, we are close to the end of our time here. I did want to point out a couple of other things that were purposeful in designing this these slides. You'll notice that you could not move the rulers, and that was very purposeful because often when I see kids moving the Pokemon, they drag the ruler or they stretch it. And stretching the ruler will really change up the proportions, especially if you shrink the length of it. But there was at least one group. Laura, was that you that did the 2 rulers? Would you tell us what slide you were on and kind of walk us through what you did there? Maybe it wasn't Laura.
Yes.
Okay.
So what I did was I took a screenshot of the original ruler because it's locked into the background, so I couldn't move it. Obviously, that was purposeful. So I took a screenshot of the ruler and then I stretched it so that it would be the same proportion as the original ruler, and then tacked it on to the top so that I could build a longer ruler.
Perfect. That's on slide 31. I just added another one so you guys can play with it. You can explore, what happens when you stretch it non-proportionally also. And then you can also do the inverse of this activity where you first supply the Pokemon and then you give them a dynamic ruler, one that you can change. And you tell the students to, you can't change the size of the Pokemon, make that the background. Now stretch the ruler so that it's correct. And that's a little bit weird and counterintuitive to measurement in the real world. But if we're talking 21st century skills, this scaling that they're doing is something that is done on computers all the time. And it's maybe not yet written into our standards, but I think could be. Any other big mathematical concepts that you all saw? I'm going to turn off my microphone for a minute. If you saw things that were standards in your class or questions that you would want your students to talk about, please bring them up either in the chat or the voice. But I hope you enjoy this task and it's something you can use.
So Kathy was asking me because she's in Canada and I'm in Virginia, and she was just wondering whether we do proportions in 4th grade. And I said, no, we just do conversions within the customary system. We don't, or metric system, we just stay within the system. We don't convert units between systems. So this would be a really authentic way to introduce the concept that in real life, we actually convert between systems and not necessarily just within the units, if that makes sense. So this could be cool. Just an extension for 4th grade, at least in Virginia. I think we're changing our standards. I'm not sure, but if this was like this past year, that would be a unique way to talk about this is how other people do it in other countries.
One of my thoughts about, I wonder if Americans are better at fractions because of the use of fractions and different units. So that's been one of my thoughts, because in the metric system, it's multiply by 10, divide by 10, and that kind of thing. But it does become problematic with like cabinetry and stuff, because a principal challenged me on this. What's half of a meter? 50 centimeters. What's half of that? 25 centimeters. What's half of that? 12.5. And then it starts getting into these really messy metric. And he said, that's probably why we still stick with imperial. But my hypothesis was that Americans would be better at fractions because of the inches and things. So I'm throwing that out to people and asking if that's true, because the metric really blends nicely with our base 10 system. I'm not saying that our students do better. It's still a challenge because it's measurement. But what do you think about fractions and your kids and how they do?
I'm going to leave that one open to the chat box because I'm sure we have some very passionate educators on this. There is so much potential for fraction learning with imperial and decimal learning with metric. But since we have 2 minutes left, I am dying to leave you all with one of my favorite songs by one of my favorite musician groups called Rocknoceros. This is a very kid-friendly group. And this is, I Wish We Used the Metric System. So I'm going to play this. Feel free to continue to chat about Kathy's question in the chat box. And when it's done, I'll log back on for questions. But otherwise, I hope you enjoy this lovely little song. So let's see, share screen, share sound. Let's just do screen.
I wish we used the metric system, but we don't, so you gotta learn the other one. It's easy with the metric system, but the other one's the one we use. An ounce weighs the birthday card you got in the mail. A pound weighs 16 ounces when it's put on a scale. A stone is 14 pounds, a penny weight less than one. And in the USA, 2,000 pounds are a ton. These numbers all fill up my head, and that is why I've always said I wish we used the metric system. But we don't, so you gotta learn the other one. It's easy with the metric system, but the other one's the one we use. You can use an inch to measure just how long is a worm. If you have 12 inches, then it's called a foot, that's the term. 1 yard is 3 feet, and it will take a while to walk 1,760, that's a mile. A league is 3 miles, and you might be 20,000 of them under the sea. I wish we used the metric system, but the other one's the one we use.
Boogie Benny, what is our system called, and what makes the metric system so much easier?
Well, Maya, our system's called the imperial system, and as you can hear, it has a lot of numbers to remember. The metric system is easy because there's only one number to remember, the number 10. When you're making cookies, you might need a teaspoon of salt. A tablespoon's 3 teaspoons, and it's not your fault. If you don't know that, 2 tablespoons are called a fluid ounce, because 8 fluid ounces make a cup, and that's what counts. 2 cups are a pint, and 2 pints are a quart. 4 quarts are a gallon, or 5/5 if you're that sort. We wish we used the metric system, but the other one's the one we use. Yeah, the other one's the one we use. You gotta learn it. The other one's the one we use.
All right, folks, happy MATHurdays. I'll stay on if you all have any other questions. I hope you enjoyed one of my favorite songs from one of my favorite bands. They're always playing in Northern Virginia at a lot of free concerts. As an update on slide 45, I have some future dates. I do expect to do at least one more session in August. However, I haven't decided yet which session that is. And these will be up on Eventbrite when I get home from my little trip to West Virginia. Also save the date for September 25th when David Porras from Mathagon is going to come and do a guest speaker session then. It should be fantastic. So if you all have any questions, let me know. Otherwise, happy Mather Days and have a great weekend.